Today we're going to see this example that you see on the screen. Our objective is going to be how do we build a bond graph model of this crash test, including the model of the vehicle, the bumpers, the seat belt, and the passenger. The question is, can we get a response or data on what the forces are generated on the driver? And that's an important consideration where we're doing the design of the seat belts and of course the design of the car itself. So let's see how we're gonna do from this real model a bond graph model. Okay, so what we're gonna do is we're going to establish some steps, some rules on how to do this. So we're going to say steps. Okay, the first one we're going to say is recognize elements and the distinct velocities. Okay, so what do we have in here? We have here we have the vehicle, which is this mass M. We have the dummy here. We have the wall in here, and we have the bumper, and we have the seat belts right here. So just so that we begin, this is going to be like a source of flow with velocity 0. This of course is a C element right here. This is an R element, and the vehicle itself is going to be an I element. And so is the person. It's going to be an I element too. But the seat belts are between the car and the person, obviously, and represented here. One with the shoulder strap and the other one with lap, or a combination of those two. So we have recognized the elements. I'm going to say OK. Now we're going to say use a 1 junction for each distinct velocity. Okay. So why don't we just say here on the back in here, we say we're going to do a distinct velocity for the wall. Velocity of the wall is equal to 0. I'll do a distinct velocity 1 for the car. This is velocity of the car. I'm going to say a 1 junction for the velocity of the driver. Yeah, that's basically what I need as a basic structure. Then the next thing we're going to say is attach the elements that experience those velocities. Very good. That's the case. You see, you have the velocity of the vehicle. It's right here. You're gonna say attached to this, of course, there is the vehicle itself with value m for mass. Attached to this, we have the dummy over here, which is the velocity of the driver, yeah. And this, of course, in here is an SF with value p equals to 0, yeah. So you see, in between here, you have the velocity. I mean, you have the seat belt between the car and the person, and you have this bumper between the wall and the car. So those are relative elements that are in between. So we need to define the relative velocities, and for that purpose I would say the next step would be use a zero junction each velocity difference. Okay, so we will need to use one of these junctions between the wall and the car, and between the car and the person. So it's very obvious that in here we'll have, maybe it's a good idea to just go here like this. So the difference of this is going to be velocity of the car. That's the velocity of the hold on, velocity of the car minus the velocity of the person. Yeah, velocity of the driver is what we're calling it. And the seat belt experience those velocities. So the last step is going to be attach the elements that experience those velocities. Velocity differences. Okay, so we have in here between the car and the wall we have this. So this will be between velocity of the car, and in here we're gonna have the C element, which is the bumper stiffness, and then there's of course the R element, which would be this other element right here. Okay, so that is the bond graph model here, and basically so far so good, and we are ready to put this into the CAMG software. But it would be a good idea to complete the causal marks, although the program puts this for you. Notice here that the one junction here means velocity of the car minus velocity of the driver. That is what the seatbelt sees. the seat belt sees the difference between this and this velocity, and that's what this is. And so we put both of those out of the C element in here. Okay, then you could say at this point you could say you could complete the causal marks or let CamG do it for you. Okay, because this is the way we entered into the CamG. Now what I would like to do is to use a different color here and show you that you just use this complete the causal marks. The way you assign the causal marks is first you assign it to the sources. This is going to be like this. The flow, but this, okay, that's the source. And then we assign it the i's and c's in integral form. So if you assign this in integral form, which is like that, this bond sets to the flow for all these other two, so these guys have to be this way. In one of these junctions that is just like this, there's only one flowing into the one junction, so the other one has to be like this. And if this is the case, you see both of these are away from the zero, so you need one input like that. But that sets the flow for these other two, and they are like this then. Okay. Where else? In Hing integral form like that. That makes this way. You see you have this two set up like this, then the zero needs one to set the effort. Now this sets the flow for the other two, and then these are like that. And we have finished the causal assignment. But what I was saying is you could let CamG do it for you. So why don't we go ahead and run the software, and then we'll enter it into the CamG software. So we go over here, yeah, like that. See that we have both of them. So we're gonna go and create a new file. Yeah, and having the bond graph on the left hand side, we can very easily do that right here. So SF like this, and then you can enter any order you want, as long as you keep the direction of these arrows the way that they should. So you can enter it like this. And then we have the zero with the this other one over here. And then you have this other one that that goes down. There you go. So you're gonna have this 0 here with a 1 junction right here, and then you will see the C and the R. And then you have them like this. Very good. Notice the graph changes colors as we go along. It's always red when it's not complete or there's something wrong with it. So where are we now? We still need to find the other 0. We need to do it. And then we have the C. Okay, we just put the seat belt on. And then over here we need this 1. And then we need the other I element. Okay, we still have 1 to go, which is this I element right here. And everything is fine now. You see my bond graph in ChemG looks like the one on the left hand side. But notice what I was saying, that the causal marks can be already added by the computer program, or you can add them by hand and just check. You should see that the causal marks that I have over here on the left hand side are the same as the ones that I have on the other. See here the causal marks. That's because the program, when you assemble the system, it knows how to assign the integral form to the I's and C's and the correct way to assign it to the sources. And so now you're ready from here to do a computer simulation, but the main thing and the main point is how do you actually go on building it. I'll review how do I do that. The steps. Okay, the steps were recognize what the elements are, then use a 1 junction to draw each distinct element, use a 0 junction for representing the velocity differences, and then do and complete the causal marks. So that's the process that we use to generate a bond graph model for a mechanical system. And so it is in the right hand side using the ChemG software. This is ready to be entered into MATLAB, something that we will do later on.